Hey everybody, this is a video addressing a couple questions that have come up today on numbers 1D and 2C from the Khan Academy practice. And the major concept from both of those has to deal with what happens when our upper and lower bounds aren't from, well, the upper is actually smaller than the lower. And this is what I mean. So when we're talking about the area from A to B, the assumption here is that A is the lower bound, meaning it's the smaller, on the interval, A would come first and then B would be second, meaning A would be less than B. And B would be what I call, what everyone in calculus calls, the upper bound, okay, or the end of your interval. Okay, so what happens when they're switched? And why does it all of a sudden become negative when the bounds are switched, when the lower bound is actually greater than your upper? So it comes down to this. If we have a graph, and I'm gonna use some real numbers here so we're not just flipping around with A and B. So this, I'll make that 2 and I'll make this 5. And there's some curve like this. It doesn't matter the shape. We are looking at if we were to take the interval or the area from 2 to 5 of f of x, and this will be f of x. What this really does is it takes into account two areas from 0. Okay, so from 0, I'm looking at taking the entire area all the way out to 5. Now that's more area than I actually want to compute. So I actually want to subtract the first part of the area. So I'm just left with the area between 2 and 5. So the calculation really goes from 0 to 5 of f of x. Okay, that's the area that I colored in. And I want to subtract away the area from 0 to 2. Of f of x. Now when I do that, I'm going to be getting rid of this little area here from 0 to 2. And the goal is you just want the area from 2 to 5. Okay, and that's how this computation really does work. And you'll see that more when we get into some algebraic questions, because we'll do those computations exactly. So what happens now if you were to look at the question where the bounds were switched? So we'll keep the illustration the same from 2 to 5. And if we have now the area from 5 to 2, how does it change the value? So what this says now is that you're taking the upper bound, which is now lower actually, that's weird. So from 0 to 2 of f of x, and I'm taking away a bigger area from 0 to 5. So what happens when you take away a bigger area is that you end up with a negative value. So from 0 to 2, this area is just right here. I'm going to call this a small area. And now from 0 to 5, that's going to be all of this area. And this is going to be bigger. So the end result always ends up being negative because you're taking more area away than you had. So in this case, ultimately when you start with the big and you take away the small, you're going to end up with the middle area. But if you were to go backwards and say, I'm going to start with the small, and I'm going to subtract away the big piece, well, then you're still going to be left with the same space, but now It's negative because you took more area away than you started with. And this is hard to see on this graph because it looks like everything is positive, but it's the same thing as if you started with $2 and then you took away $10. Now, well, that's -8. So it will be the same thing as calculating the area from 2 to 5. It's the same region, but now it just becomes negative. Okay, so how does that work in the problems from the Khan practice? So 1D is from 5 to -5 of f of x. Well, the issue here is that the upper bound is actually less than the lower bound. They're in the wrong order. So with the property that we saw above, if we just switch the upper and lower bounds so they are in increasing order, meaning this number, the lower bound, is smaller than my upper bound, the outcome just becomes negative. Because here, you're taking a smaller area and you're subtracting a bigger area, which will end up being negative. So to compensate for that, you can look at equivalently switching the upper and lower bounds back to an increasing order and then just making that value negative. So when I do that, -5 to 5. So if I make a little picture here of what's going on in the question, I know I'm going to be over here. There's a -5. There's a 5 over here. There's a -1. And there is a 3. So these different regions, there's 1, there's 2, and then there's 3. So from -5 to 5, that means this is the entire region here. That area is 10. From -1 to -5, or -5 to -1, this region right here is 4. And then from 5 to 3, this region has an area of 9. Well, what doesn't make sense here is that, well, 4 plus 9, that's 13. That's greater than 10, the overall area. So what has to happen in the middle is that this has to be a negative area. And furthermore, it has to be -3 to get an overall 10. All right, this value right here has to be -3. So looking at from -5 to 5, -5 to 5, if I go in that order, then the answer should be 10. But because I don't have the correct increasing order of my bounds, it has to be negative. Okay, I'm starting with a smaller area, and I'm subtracting a bigger area, so that'll always come out to be negative. And it's the same concept in the next question. Different bounds, and I'll make the sketch here of the different area regions first. I like to do this because it conceptually helps me understand what I'm subtracting and what area that I'm actually looking for. Here's -2, here's 0, and then 8 can be over here. So my different regions are from -8 to -2. That's 11. From -8 to 0, so now we have an overlapping piece here. This is going to be 5. And then from -2 to 8, that's going to be -5. So this one is asking from 8 to -8. Now look at the bounds for g of x. The lower bound, 8, well, that's greater than -8. So we can equivalently write this as the opposite sign of the area from -8 to 8 of g of x. So solve this question, and then you can just make the sign negative. If it comes out to be negative, then it will end up being positive because you'll have two negatives. So to do this, we have to find from negative 8 to 8. You're looking at what is the total area from negative 8 to 8. Well, I have 11 here, but I have 5 here. Okay, so what is this region? 11 plus something has to give me 5. Well, that means this area has to be negative. So 11 plus what would give me 5? That would have to be negative 6. And then I don't really even need that for this question, because if I look at 11 and negative 5, that covers the entire region from negative 8 to 8. So altogether, I know that this will be 11 plus a negative 5. So from negative 8 to 8, we have 11 plus a negative 5, which is a positive 6. But what's true here is that I have to make it opposite in sign. So it's going to be negative 6. I think that covers it. This is a difficult concept. You will get some more practice on this. Thank you for all your questions. And if you have any more, please don't hesitate to message me. I can make these videos for you pretty easily and get into some nitty-gritty. Hope everyone's well. Take care, and we'll talk to you soon.